There you go. This is a template we're going to work with. This is a plan view, level 30. If you click on the 3D view, we have a building like this. Okay, so it's a building, 2 floors and a basement. If we go to the back view, well, this is level -15, probably on the east elevation, we have all the levels. Okay, so there's a basement, and then we have level 0, 15, and 30. It's the roof. Okay, so that's it. If you open level 0, you will find a building. So there's a corridor. We have here. This is an educational building, so we have classrooms and offices. Okay, so these are classrooms. We have 3 classrooms, and here we have office spaces, 1, 2, 3, and this is another office space. Those are hallways or mechanical rooms, and here we have the restrooms. So today we're going to work with the air ducts, and when we're starting the piping and the drainage, we will work with this part of the building. Okay, so we're going to work with this building for a few weeks, couple of weeks, or probably 3 weeks. And today, the first thing is to work with the ventilation, with the air handling unit and the air ducts. Okay. And at least those classrooms we can annotate a line. So the size of this classroom is 40 feet by 30. Okay, so it's not big. It's slightly bigger than this. I think this size is around 20. This classroom is around 20 by 20. Okay, so yeah, it's bigger than this. It's almost double. So how many people can we have here? And we have to start talking about people, and because the number of people affects the CFM. If there is a classroom like this with okay, if this is a classroom, how many people can we have in 40 by 20? We have to dimension everything for the maximum number of people. We can have maybe in this classroom there are only 5 people, the teacher and 4 students. But what is the maximum amount of people that we can have in a classroom like that? Okay, this is 20 by 20, and we have 15. So in something that it's double, 40 by 20 something, we can have 30 students. Okay, so let's say that in this, the occupancy, it's 30 people. Okay, in the classroom. So what's the CFM that we have for per person? Well, there's a number that you have to remember, and that number is 20 CFM per person. Why 20? There are tables, and depending on the activity that we are doing, we require more, because CFM is the ventilation, is the amount of fresh air that we need to supply every cubic feet per minute. So every minute, I have to supply 20 cubic feet. Okay, so this is cubic feet per minute. CFM stands for cubic feet per minute. And per person. Okay, so in 1 minute, we have to supply 20 cubic feet. It's a lot per person. And then how many people do we have? 30. So we will end up supplying 600 CFM. Okay, every single minute, we have to supply 600 cubic feet. It's a lot. And if that air comes from the outside, because here remember that the goal is that we will have the air handling unit here. And then there will be a duct. And here we will have a supply diffuser. So from this supply diffuser, we need this 600 CFM. And then we need a return. So we need to return this. Down. Okay, so there will be return pipes. In Revit, for some reason, remember that the return inlet in the air handling unit is this one, it's not the other one. So we will have to do something like this. And we have to return exactly the same amount of air. (600 CFM). Okay, so this is what we have to do, but we have to do this many times. It's not just a room. Now we have a building, and we have to supply 600 CFM, all the classrooms, and then we have to supply less airflow in the office spaces, because we have fewer people there. But basically, this is what we want to do now. We have to supply this. We have to place the supply diffusers, and then we will have to place the return diffusers, 600 CFM, 600 CFM, and this is the air handling unit. Next week, we will connect the heating and the cooling coils, because you remember that in the air handling unit, there will be a heating coil, and there will be cooling coils. And then the heating coil and the cooling coil will be connected to something that it's, we have a boiler, we will have a chiller, so we will have to connect this to the heating and cooling system. But this is the ventilation. So even if we didn't have heating and cooling, we will have this. And why are we doing this? Because we want to save energy. Last week, when we calculated this on with the psychrometric chart, we didn't have return. Okay, with the psychrometric chart, what we had was just this. We supply 600 CFM from outside, and then we heat up this air, and then we have the supply air. So this is the first schematic view, and this is what we calculate last week. We're not doing that anymore. Okay, so now we have to recirculate this, and then we need to take the air from here, and we do need here we go. Okay, so this I'm going to extend this pipe, and I'm going to use another color, because this is the air, the fresh air that comes from outdoors. Okay, so here this is the heat recovery. So here we recover heat. It's always something like this. This is the heat recovery. And then we have the heating and cooling coils. Okay, so this is the schematic view. Now we need fresh air. We don't just heat up the fresh air and that's all. We can change this, because this is the fresh air. Okay, with this schematic view, we have fresh air, we heat it up, and then we supply. Here, it's more complicated because we get the fresh air, we mix the fresh air with the return, and then here we have the result of this mixture. It's something that it's not as cold as this air, and then we have to heat it up, but less, and then we have to supply. So these are the two elements. We are not allowed to do this anymore. You might find some systems that were designed like 40 years ago, and you might find something like that, but this is not allowed anymore. We have to recirculate this, and we need heat recoveries on our air handling units. So that's what we have to do. And now the challenge, we have to understand basically what we have to do. And now the challenge is to do this in this building. So we have a building, it's not very difficult, but well, we have 2 different floors. Okay, so we have the first floor, the second floor. They are the same. So whatever we do on the first floor, we can do it on the second floor. And if we're working with Revit, I recommend you finish one of the floors and then copy everything up or down. It depends. Don't start doing both floors at the same time if both floors are the same, because it will work a lot and it's more difficult. So we are going to do this. We're going to finish the first floor. And then when we are done with the first floor, we will copy it to the second floor. And then we will start doing the vertical systems. So first, how can we do this? We have to place the air handling unit. This is because that affects the ductwork. So we will study the building, and then we will decide what the best place for the air handling unit is. And then we have to study the building, and we have to study where the vertical pipes are going to be. When we have made those decisions, then we have to start placing supply and return diffusers, and then we will start with the ductwork. Okay, but don't start placing ducts like headless chicken, like because then you will have to do it again. So first, think about it, look at the building, study the building, and then we can start placing diffusers and ducts. So we have 2 floors. We're going to study with the first floor, and then whatever we do on the first floor, we will copy everything to the second floor. But make sure that you are done with the first floor before copying it, because the system will get more and more complicated, and then you don't remember what you have copied and you have not. So let's make sure that we are done with the first floor, and then we will copy. So we only have 2 floors. Oh, and we have a basement. Today, we're not going to do anything with the basement, but probably the boilers or the chillers, they will be on the basement. Okay, so the air handling unit will be on the roof, and then next week, we will connect something, some machines or some heating and cooling systems that are in the basement. But today we're going to work with the roof and the first floor. The 3D view. Okay, so you see that this building, we have a lot of, what is this? Those are shafts. When we have a vertical element that goes all the way down from the roof up to the basement, we call this a shaft. Okay, so what are shafts? Are so we have something like this. Imagine that this is different, and there are 2 floors. Okay, so we have 2 floors with the same flow. So now we need a vertical element that goes all the way down. And then we need a horizontal branch. Like this. So we have to rotate this, And we have the 600 CFM here, and there will be 600 CFM there. Okay, if there are two floors, this element, we cannot have a vertical pipe here in the middle of this room. We have to hide those vertical pipes. And why do we have to hide them? Because they are not beautiful, and second, we have to protect them. Okay, so if those ducts are exposed just by hitting them or whatever, we can have air leaks. So when we have a vertical pipe, we don't have to protect these ones because it's very unlikely that we can touch them or we can hit them. Well, we can, definitely try, but I'm not going to do it. Okay, but if we have something vertical here, we can hit it without. So we need shafts. So at least here, probably on the first floor, we don't need a shaft because well, it comes from the ceiling and it's here, and we don't have a vertical pipe here. But in this place, in the second floor, we need to protect this vertical pipe. So we need a shaft here. And the same thing, we can have the same thing with the return. So imagine that the building doesn't end here, and there's another. Okay, so we might need another shaft. Here. There you go. Okay, because there will be another return. Okay, so that can be a shaft or can be different mechanical rooms, or we can do this where we have the restrooms. Okay, but we need vertical elements that can go. If this building has more floors, then we need to extend the shaft up to the first floor or up to the basement. It depends on where on when we have all this. So if you can see, we have the shafts in this building. Okay, so we have shafts here, here, and we have 3 here, and there's another one there. So then we have to study the buildings. If we work with the wireframe, so we see that we have this shaft, and this here we have the restrooms. So this can be good for the drainage system. Okay, so we're going to save this shaft, this vertical element, for the plumbing and drainage. This one here. Here you see that in every single classroom, we have 3 different shafts. Okay, good. And remember that we had another one here. Okay, so we have another one, another shaft here. And then we have another shaft there. Okay. So probably this one, it's for the basement, because on the basement where if we need a boiler or we need something like that, we need to get rid of the gases that we are generating there. So probably this is good for the things that we're going to have on the basement. This connected to the classrooms, I don't know. I would use this one as the main vertical duct to get to all the classrooms of that building. Okay, so I'm going to use this one. So if I'm going to use this as the vertical pipes to place the vertical pipes from the air handling unit, this is not accurate because here I have a duct for the supply and we have another duct for the return. But that means that I need 2 shafts. So I'm going to try to place both shafts, both ducts on the same shaft. Okay. So why? Because we have to save space. Our client is not paying us for losing space in our building, because if we have to place this, we're losing that room. So our client doesn't want that. So the fewer shafts, the better. So that's why we are going to try to place the return and the supply here on this one. Okay. So if this is the shaft we are going to use, now the air handling unit should be close to this one. If we place the air handling unit here, there will be a lot of a long duct from the air handling unit to that shaft. So first, we have to decide where we have this vertical element. And when we decide where the vertical element is, then the air handling unit should be close to that one. Okay, so this is the first decision that we have to make. The air handling unit is going to be close to this one. So this is the first thing we're going to do. By the way, make sure that we're working in a mechanical discipline. Discipline should be mechanical. You notice that because we can select the walls. If you change to architectural discipline, then you will be able to select the building, but we don't want it. Okay, so we are not going to change the building. So we have received this from the architectural department, and we are in the mechanical engineering department, and we can't change the building. If we have to change something, then we will, but try to abide by the original design. So let's go to systems, and here in mechanical equipment, the first thing, you see that we have a lot of elements here. Okay, so I have uploaded a lot of families. So we have to go first to the air handling unit. So here we have air handling unit, horizontal. And remember that this number is the size. So let's select something in the middle, like 12 square feet. And let's place it here. Okay, let's place it here. But now let's analyze this. By the way, where is it? Make sure that it's on the roof. Well, it's on level 0. By default, it's on level 0. So if you go to the east, it doesn't make sense. So it has to be on level 30 is the roof. And the elevation 0. Okay, so make sure that the air handling unit is on the roof. Cannot be on level 0 or level 15. Okay, so this is the air handling unit. So this is the air handling unit. And here we have the outlet. This is the supply. And here we have the inlet. If we rotate this, well, we know this because we studied this machine last class. We have 2 inlets here, and this is the outlet. So this is the supply, and the one on top, this one, is going to be the return. So if we want to go in this direction, I think the best thing we can do is to rotate this facing the shaft. And I think it's going to be easier because we just have to go this way and then downwards. Okay. So, and that decision it's important because when you start doing the duct work and you start connecting ducts to the air handling unit, if you, I want to change it, it will be a mess. So that decision, it's important. And this is the first decision that we have to make, where we place the air handling unit. Okay, so I have decided to place it here because if this is the supply, it's quite easy to go down in this direction. Okay, next. If we work with level 0, so we have level 15, level 0. So I'm going to start placing for the classrooms. I'm going to design the classrooms. And in a classroom, well, we can do something like this, for example. Okay, so in this classroom, we have 2 supply and 2 return diffusers. So let's do it. We have 2 supply diffusers and then 2 return diffusers. So in each classroom, we're going to have 2 supply diffusers and then 2 return. Do you want to put supply here and return there, or the supply here and return there? It doesn't matter, I think. But the thing is, the criteria is that supply and return diffusers, they have to be as far as possible. So we cannot place 2 supply and return diffusers too close to each other. If there is a room and people are here, and this is important, the height, and I haven't checked the height of this, but the height of the room compared to the height of people, it's important. We have an occupied zone. So this can be 7 feet maximum. This is what we call the occupied zone. So comfort has to be here. I'm not worried about conditions here, because people are not living above this limit. It's very unlikely that there's someone taller than this. So I'm not concerned about the thermal conditions there. I'm concerned that all my sensors of temperature and relative humidity will be here. Okay, so those are the sensors, they have to be in the occupied area. So if we have a diffuser here, a supply diffuser, and then I have a return diffuser there, this can happen if I supply air and I have this return diffuser very close. So it's possible that this happens, that the flow goes this way and then it finds a return diffuser very close and it doesn't reach the occupied area. So this is a big mistake. So we should place the return diffuser as far as possible so that the supply is doing this, and then the return is doing that. So we have to make sure that the airflow covers this occupied area. So if we place the return and the supply diffuser very close to each other, it doesn't happen. So that's the first criteria. If we play supply diffusers here, then the return diffusers should be here. So you see this room, and this is what should happen. So let's place the air terminals. If we select air terminals, by default, I don't know if you have return or supply. Well, we have 3. We have exhaust. We will use this for bathrooms, the exhaust diffuser. So now we have to place supply and return. Another rule of thumb, we should have the same number of supply and return diffusers. If we do this, everything will go well. If we don't have the same number of supply and return diffusers, then it's possible, we can do that, but calculations will be more difficult, and probably the layout will be different and it won't work well. Okay, so the first rule of thumb, if we have a room, analyze where we place supply and return as far as possible. Second, same number of supply and same number of return diffusers. Another rule of thumb. And third, the size, if we have exactly the same number of supply and return diffusers, the size should be the same. So I don't know why, but in return diffusers, I have 24-24 and 12x12 connection. This is 24-24 is the square, and then 12x12, it's you see that we have 2 squared. So that's the size of the diffuser, and this is the size of the connection. So the 12x12 is the size of the connection. So this is made for a 12-inch duct. We can change that, but if we have only this 24 and 12, so let's try to select something similar here. So you see that we have 24, 24, and 12 neck. And neck means that it's a round. You see, this is round. And 12x12 means that it's square. Anyway, this is what we have. You can upload another 24 by 24 and 20 neck for a return diffuser, but let's do this. So let's place this one, and if we place two, we can have one here and another one there. Okay, it's a supply diffuser because if we select it, it's a supply. And if we look at this, the arrows are going outwards, so that means that this is supply. Now, because now we have another requirement. We have the, oh, by the way, before doing this, what have we done? We have placed this on level 0, that's fine, but where are they? Let's look at the east elevation. This is not, okay, because they are on the floor. So we have to change the elevation, select the diffusers, and then the elevation, we have 15, okay, so the height is 15. Well, we don't have these nice dots with this perforated. So what do we need here? We have a diffuser, and we need a duct like this, the minimum duct, and then the main supply diffuser will be like this. Okay, so that's going to be flex duct. So we need a return diffuser here and flex duct in this direction. And this is the slab. Okay, if this is 15 feet, we know that at least we need 10 feet free. Okay, so the minimum distance between the floor and the supply diffuser should be 10 feet minimum. And then we will have 5 feet from this to the slab. I think it's too much. I think if this is 12, it will work. Okay, but keep in mind that this is 12, and then the duct have to be higher, and we need to have enough space for this flex duct. If we don't have enough space, we will find out. So don't worry. So this is okay. So we have to select the diffusers. Select. I want to select both 1 and 2, and I can change the elevation here. So let's make it 12 feet. Okay. Will we have enough space here? I don't know. Let's make it 11. I think 12. It's gonna be okay. So 10 is minimum, 11 is better, 12 will be even better, but I don't think we will have enough space here if it's 12. But first we have to change the elevation. Okay, so once we have changed the elevation on level 0, we have this, and okay, so we're if you are working with the classrooms, so we're going to copy once we have the right elevation. Now we will copy these diffusers. Okay, so we have all supply diffusers here. Here we have the office spaces. In the office spaces, we have, oh, we're not done. And before copying, sorry, I want to check something else. Okay, so the airflow, if we have 30 people, we have 20 CFM. So the airflow is 600 CFM. Another rule of thumb, all diffusers have the same airflow. Okay, so everything is common sense. Supply diffusers and return diffusers, as far as possible, the same number of supply and return diffusers. And then if we have 2 diffusers, we have to make sure that both diffusers have the same flow. If the flow of this room is 600, so each one should be 300. If we click here, By default, the flow is 500 CFM. So we have to change this. We have to make it 300 and 300. Okay, so that's why it's better if we do this just with one classroom, and then we can copy. Once we have the right diffusers, the right place, right elevation, the right CFM, and then we can copy this. So copy. And now all of them are 300 and the elevation is the same. And 3D view there. Okay, then we have the office space. So the office space is different because we don't have we don't have 30 people. How many people can we have in an office? 1, 2, let's say 5 people maximum. Times 20 CFM, it's just 100 CFM. So that would be 100 and 100. And the more the airflow, the more diffusers we need. So if we have 600, we might need 2 diffusers. That makes sense. But if we have only 100, 1 diffuser would be enough. Okay, so now we can do this. I can copy this one because this one has the right elevation. It has the, well, we have to change the flow, but I will copy this one here, and I will change the airflow because this has to be 100 now. So this is 100. And I know that here I'm going to need a supply and return diffuser. Okay, so I'm designing the supply. I copy 1, 2, and 3. Here, I don't have information that those are most likely, well, those are the restrooms, and those are like mechanical rooms or the janitor's room or whatever. So those are not, and then in the hallway, I'm not going to place any diffuser either. Okay, so I'm going to place diffusers only in the spaces where people live and where people stay. This is something different in this lobby. Okay, so you see that we have a big flap here. That one. Because this is not just a hallway, it's a lobby, and people can stay in this lobby. Okay, but in a hallway, we usually, in a narrow hallway like this, we usually don't place diffusers. It depends, but in this small building, I don't think it's necessary. And here we have another office space. Okay, so here we have rooms. Probably one of these is a shaft, and these are tiny mechanical rooms or whatever. So that's the office space. Okay, so if that's the office space, I'm going to copy this one, and I'm going to place a supply diffuser, and then the return diffuser will be there. Okay. So from time to time, we have to check, especially the elevation, make sure that all the diffusers have the same elevation and they are all on the same floor. We're dealing with the first floor here. Okay, so I think we're good with this. We don't need more diffusers because this area and this area, people are not staying here. So those are the office spaces and the classrooms. This is what we need. Okay, so when we are done with the diffusers, and we make sure that they all have the right airflow. Okay, so check that in the office we have 100, in the classroom we have 300 each. Then we can either design the return diffusers or the ductwork. Let's start with ducts and see what happens. Okay, so here we have ducts. So I select duct, and I'm going to select the round, default round, because it's easier, depends. If we are going to have exposed ducts, round are better, they are more appealing. If we are going to hide it, probably the rectangular ones are better. But let's work with the round ducts, and let's do it. So here, we have to check diameter 12. Okay, let's start by 12, but probably we will have to change it. But let's start with 12. Okay. And okay, so where are we? This is the duct. We are on level 0. Upper end, middle elevation, it's 40. It doesn't make sense. Let's do it and let's see what happens here. So first, I don't see it. Why? Because it's here. Okay, so I have placed this on level 0, that's fine, but the middle elevation is 40. I don't know if you have the same issue. But what I want, if I'm placing this on level 0, if the elevation of the diffuser was 11, the elevation of this can be 13. Yes, okay. So there should be a gap between the slab and this. If this middle elevation is 14, it doesn't work because the duct is in the slab, so it's impossible. So I think the right elevation is 13. There you go. Okay, and now level 0, we'll see it. And now we have to connect this to the duct. And the best way to connect diffusers and ducts, but just the terminal connection, okay, so the connection between the main duct and the diffuser, it should be a flex duct. So I right click here, draw flex duct, and then I have to click here. So here we have an active point, and now we do this. Okay. Okay, so now we have to connect this one too. Yes.
Would you rather us have the flex ducts rather than connect the ducts straight to the
Let's try to do it. Okay, so imagine that we have this, we draw that, and we try to connect this here. Well, doesn't work.
Well, when I drew my ducts in originally, I drew them on the diffusers and it connected them
Automatically.
Yeah.
Can you show me what you did here?
Yes.
Where's your mouse?
Oh, I didn't mean.
Yeah, there are. Okay. Oh, you did this? No, no way. No, 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 no.
Okay.
No, we can't do this because, okay. Yeah, it works, and it works without flex ducts. Okay. Well, it might work. Yeah, but we have to connect this to the air handling unit eventually. So it might work if we remove this elbow and then we extend this here. Okay, but now we have to connect these two. I'm going to remove mine. Okay, we drag this here. Did you do this? Do you have the T?
Not yet.
Okay, do it. Okay, in this way it might work. Okay, but connecting two diffusers. Yeah, eventually we have to connect two diffusers, but we need a T. So well, that's another. I don't like this because the elbows should be. We have to make the flow easier. So if we can connect a round elbow, yeah, that looks better. Okay, so if you have the opportunity to create this kind of elbow, it's better. So that's why I use flex ducts, because the movement of the air, it's easier with the flex duct than okay, but this might work. Okay, so thank you for showing us another way to do it. I usually work with flex ducts because in the real world we use flex ducts. Why? Because if we make a mistake here, we have constraints, and we have this T, and if the T is not exactly on a perpendicular with the diffuser, working with this duct is impossible. So having a flex duct gives you flexibility if you have made mistakes placing things. But theoretically, that would be a way to do it. But okay, it's fine. But I think I'm going to work with the flex ducts. And I'm going to work with the flex duct because we have flexibility. Okay, so if we make a mistake placing things, we can, working with this, yes, we can, we have a tolerance so that, okay, so with the flex duct, we can handle it. So now we have to connect this to this one. If we do this using flex ducts, then we come here, we have to highlight the central axis this way. And by default, I don't know why, but in Revit, by default, we always have this. And this is not good. Well, you see that it's not good because the angle is too. So if that happens, we have to delete the duct. And we have to rotate this T. You see that we have rotation here. We rotate the T in the right direction. There you go. Okay, so if we have a T facing the diffuser, now we right click, flex duct, and the element you're going to do the different system classification. Okay, so that's interesting. What's wrong? Oh, my goodness. I don't know if this happens to you, but to me, this is an exhaust air duct. Okay, so check, because this can, we have this warning, it couldn't happen, it has to be supplied. And this has to be supplied. And this is supply, and now everything is supplied. Okay, so I don't know why it has happened. But now we have to check the flags. So if we make that mistake, if we use return ducts or exhaust ducts, and we connect this to the supply, so this is 300, the airflow, Okay, so the flow is 0 CFM. Why? Well, maybe I did something. So let's do it again. So we have to type here 300 again. I don't know. It happened to me probably because Sterling came here and you did something wrong. But anyway, now it's 300. This is 300. This duct should be 300. Okay, so that works. This duct here should be 300. Okay, good. This is 300. And if everything goes well, this should be 600. Yep, it works. Okay, so make sure every time you connect two diffusers to the main duct, please check that the airflow is correct. Okay, because if we keep placing ducts and we have 40 or 50 diffusers and the flows are not correct, then we can find out where the mistake is. Okay, so make sure that every time you connect two ducts, make sure that this duct has the right flow, because we need it 600 for this room. Okay, so at the end, we should have 600 here. Okay, good. I think it would be better if we just remove this and we can copy the whole ductwork, because now we make sure that we have supply diffusers. We don't have to do this 3 times. If we do it once, then we copy and make sure that we have 600 here and 600 there, and it goes. Okay. So 6 diffusers, 3 ducts, 600 CFM. Now we need because what are we doing? Usually the main duct, it's something that goes through the hallway. Okay, so we pull or we have to make that those ducts go out. Okay, but because again, the fewer ducts, the better. So having the main duct going across a classroom or I wouldn't do it. Okay, so that's why we have hallways. So we make sure that we move this out, and then the main duct is here. So all these diffusers or all these branches are connected to the main duct. So let's do this. So from here, there will be a main duct in this direction, and then we have to connect those diffusers that we have in the, I'm going to move this closer to the wall, and I'm going to use a duct with what elevation? Now this is important. If this duct, if the middle elevation is 13, now this duct should be 13 too. And another rule of thumb, as we're connecting more branches, the duct should be bigger. Okay, so if we have started with a 12-inch duct, here we have 12 inches, here we have 12 inches, and here we have 12 inches. Does it mean that here should be 36? No, it's not that way. But it should be a little thicker than this. So what kind of ducts do we have? If we, we can select the diameter here. So the diameter at the end, let's make it 16. Okay, so I'm going to make a diameter of 16 here. Now I'm going to make it 14. duct 14. And if I click here, there will be a reduction. Okay. And finally, this is going to be 12. Okay, that makes sense. So when we are connecting different branches, the diameter of the main duct should be thicker, or as we are branching out, the diameter should be thinner. Okay, it depends. So our first diameter is 12. Well, this can be 16. We will check this when we know more. Now we don't know anything about velocities or friction or all that stuff. But this is common sense, okay? So as we are connecting different things, the diameter should be thicker. Okay, so we can start with the last one. So we can connect this directly with the flex duct to this one, and it works. Okay, so this is the last diameter. And then if we have the same elevation, that's easy. If we have different elevations, so again, I insist, if the middle elevation here is 13, the middle elevation of this one should be, okay, so it's 11. Let's do this, see what happens. Okay, so this is wrong. The middle elevation here is 11. So let's try to connect this and this, see what happens. It works, so Revit does it, but we are we have a lot of small ducts here. Okay, so Revit does it, but nobody will do this in the professional life unless there is a reason for that. Maybe we have two ducts that are crossing, and then one of them has to be lower than the other one. Maybe that there's a reason for that. But if we don't have a reason, I wouldn't do this. Okay, it works. And if we can change this round elbow, it works. But look at this tiny duct we have here. So having this tiny duct means that there's a guy taking this measurement, and this measurement can be 1 inch or 2 inches, and they have to cut a slice of this duct, and then they have to fix it. It's too much work, so nobody does it. Okay, so if you submit something like this to the workers, they laugh at you. They would say, "This is the architect. Yeah, in Revit everything works," but they won't do this, or maybe they do this, okay, because they don't get along with you, and you say, "Okay, you asked me to do this. I'm going to do this, and I'm going to charge you a lot because it's a lot of work." Okay, or if they are good enough, they say, "Okay, this is an architect's mistake. I will do it well because I know how to do it." Anyway, so I'm not going to do this. And when I'm inserting these pipes, so I can select this. And well, once we have 2 of them, I can change the elevation. So I'm going to leave this, and I'm going to change the elevation of this one. I changed the middle elevation to 13. And now with the duct, I also measure the supplier. Oh, that's interesting. This is exhaust. Why? It should be supply. Okay. Sometimes we have the warning, you are connecting a supply to exhaust. Sometimes we don't have the warning. So that's even more dangerous. Okay, so make sure that we are working with the supply. And this is supply, everything supply. So now we go and select 14. And click duct 14. The middle elevation, it's 11, it should be 13. Then I do this. Sorry?
I think we'll let let me like select like return air for system air. It only shows like return. Okay, I'm trying to think of it. I'll look there.
And what are the features of the selected?
Oh, that's really good. Okay, so.
The error. If the error is in, the return back something instead of this black. But as long as everything is returned, in your case, that the error is.
Okay.
Okay, so now this is 14, the elevation is 13, so I can go. Okay, I want the first one to be 16. 16. Then the second one, 14. But don't select this. Okay, select that. Now it's 14. The elevation is 13. Okay, so I can do the second. And now I select that again. Elevation 13. I change diameter 12. And I go to the last one. So let's make sure that everything is correct. This is exhaust. Line. This is supply. This is supply. And this is supply. Okay, so now everything is supply. All the elevations are 13. So if we look at the 3D view, okay, so we are shrinking the pipe, but we always have the same elevation. And now if we connect this, it's much better because we have everything is cleaner. The fewer elements we have, the better. Okay, so now it looks much better than before. And we can connect this with a flex duct. There you go. And now let's check, because here we have this one is 100. Yes, this one is 300. This one is 300. So if we connect 300, 300, and 100, this should be 700. Let's check. And it's 700. So things are going well. And now if I connect this here, okay, and this here, good. But now we have to connect this one and that one. So I'm going to do this with a flex duct here. By default, I don't know part, but this T is always, again, it's not wrong, but nobody will do it. Okay, so delete this, rotate the T, and now draw a flex duct here. And finally, rotate, and flex. There you go. Okay, so check the 3D view that there is not, it's very easy to make small mistakes. And again, the company will fix all your small mistakes, but you don't make it. And now, if we want to make sure that we have done everything correctly, if we keep, so what's, we have 3 branches, and each branch is 700. So here the flow should be 2,100. Let's check. Yeah, it's 2000. Okay, so all these connections are good. We need a reduction, we need T's, but everything goes well. Another rule of thumb. Well, I didn't explain you that because I have experience doing this, but don't try to create. There are, okay, so here you have duct fittings. Okay, so in duct fittings, we have T's, and we have, well, I have uploaded a lot of things, especially T's. You can find a fitting. Like this. Okay, so we can have a duct in this direction, another duct in this direction, and then we can have a branch like this and a branch like that. So can we have this fitting? Yes, we can. Is it better? And we can have even different things. Imagine that this is 12-inch diameter, and this has to be 16. Can we find a fitting, and this is 10 and 11? Can we find a fitting in which we have 16 here, 11 here, 12 there, and 10 there? Maybe we have something like this in the market, but I don't recommend you do this. So using the Julius Caesar technique on work, divide and conquer. Okay, so if you have different branches and something like that, and you have reductions, divide and conquer. Okay, so if we need T here, let's design that T. If you want to reduce the size of this, then use a reduction. And then here you can use another T. Okay, so if you divide the problems, if you try to solve all the problems at the same point, it will be very difficult. So divide the problems. If you want to connect a branch, reduce the size, and then connect another branch, divide the problems. Don't do everything at once because it will be much quicker. Okay? So this is what I will do. But again, if you deal with the company and they tell you, no, it's better, we have this system and you can connect here 4 branches with different sizes. If they have such an element, okay, do it. But if you don't know, let's do this. Okay, so let's try to. So that's why when we are designing the layout of the diffusers, don't place this diffuser right here, very close to that T. So leave a space between this and that, and that will be easier. Okay. So we're almost done with the, we're not because we have this one here. Okay, so for this one, this is just one. So probably if this is 16, so the diameter is 16, and that will go well because from that point, then we have to go to the vertical, and then we have to go all the way up to the air handling unit. But probably if we have to connect this last diffuser to this, the duct here can be the elevation, it's 13, so make sure that the elevation is the same, but the diameter 12 will go well with this. So I'm going to reduce this size, then I'm going to go in this direction, and then I'm going to select, I'm going to move it closer, and I'm going to select the flex tab. And this I don't like this kind of elbows. I like this. Let's look at the 3D view. And okay, looks well. So the airflow here should be 100. Okay, the airflow it's 0. Supply, exhaust. Supply. Supply. Okay, so this flow is 0, so it should be 100. Okay, check the CFN because it's very easy. Making mistakes, it's very easy. So every time you draw something, make sure that the flow is correct. Because if you do this and you don't check the airflow, you don't know where the mistake is, or probably you have a lot of mistakes. So check the airflow. Okay, so now we have probably the most difficult part because we have to connect vertically this to that. So before doing the vertical stuff, if I think I'm done with the air supply, with the supply diffusers, I think I will copy everything to the, yes.
I'm just having a little trouble like locating the download to the myself. For the sign off,
Okay, so when we think we are done with the supply, then we select this on the elevation and then we copy. And let's click on this. And now we have 2 flows. Okay, so I told you that probably, yeah, now we have everything connected. And but now we have to connect both to the air handling unit. Okay, so first we have to edit this air handling unit. The maximum pipe here is, yeah, the biggest pipe is 16, and this is 16. Okay, so now if we connect 2 pipes of 16, it should be thicker. Okay, so let's say that this can be 20. Again, 16 plus 16 doesn't have to be 32, but more than 16, 18, 20. So let's make it 20. And here, this air handling unit, we have this huge, this is 65 by 47. We are not dealing with those pipes. Okay, so I think I showed you how to edit the type of this. So if 20 is fine, let's make all these supply and return outlets and inlets. Let's make it 20 by 20 inches. 20. Okay, so now everything is 20 by 20, and yeah, probably this air handling unit is too big for this building, but well, but now this is 20 by 20, and the maximum and the pipe is going to be 20 round pipe. Okay, so if we go to the top view now, okay, so we have the air handling unit. We have to go in this direction, then we have to go down. And then we have to connect these 2 pipes to the vertical one. Let's see how to do this. If we want to move vertically, if we are working with the plan, we can do that by changing the elevation of this. Okay, so from this one, I'm going to go out, draw that, and I have to make sure that I'm within this shaft. And now if I do this horizontally, it doesn't work because it's here. Okay, so we want to go down. So if we want to go down, what shall we do? Click this pipe, this duct, make sure that we are within this, and then look at the elevation. The middle elevation is 0 feet 11 inches. I have to go down. So if the middle elevation of this is 0, then I have to change this to, let's say, negative 50. It's too much, but I want you to see what happens if we draw that and the middle elevation is negative 50. Okay, so we have done something, and then we can move horizontally. Let's see what we have done. Okay, it's too much. I know that 50, it's gonna be too much. Okay, no problem. What the hell is this? But now, once we have this vertical pipe, I can move it upwards here. Okay, so make sure that it's shorter than this. Well, those are square pipes. Let's make them round. So let's select round. And well, as you can see, this doesn't make sense. Okay, so I'm going to delete all these. And if we try to connect to round ducts, the elbow would be a round elbow. Okay, I don't like these round elbows, so I want this better. Okay, so now it looks like that. Okay. Now this is tricky in Revit, and well, the more you work with it, so let's try to drag this until this axis here and see what happens. Well, if Revit can do this correctly, life would be beautiful. Okay, not bad. You see that Revit has made a lot of decisions. We have a T here. It's connecting a 16 duct to a 20-inch duct with this elbow. Well, that's fine, but this is not what I want, okay? Because when we have two of them, when we have two branches, if we have 16 here, 16 here, then the duct here should be 20. But after this point, we can have a reduction, and this can be 16. Okay, so I'm going to do that. I'm going to change the diameter of this pipe to 16. And well, Revit it's incredible because it has adapted this T to the 16. Okay. So I want 16 up to this point. So I'm going to delete this. Okay. And now this is 20. And this is 16. When we connect this to this, I'm gonna need 20, but then we can have a reduction. Okay, so how can I do it? Yes, how can I do it? I'm going to select this and I'm going to copy this horizontal pipe here. Okay, so now on the second floor, I need to connect this to this, and in Revit, T will show up. There you go. And now I'm going to connect this to the 20-inch pipe, and another T will show up. Let's see. Yes. And then just here, I can use a reduction. So I'm going to draw that, but I'm going to draw that. Okay. Look at this. If I'm working on the 3D view, I can't go down. So probably I would have to go to the east elevation. Yes. So on the east elevation, if I draw that, and this duct is not 20, I should be able, okay, I can change diameter here, 16. Yes, this is what I want. And I have a reduction here. And finally, if I move okay, so I have this duct here and this duct there, and it doesn't work. Why not? Okay, now it works. And now I want to change this around that. Okay. So this is exactly what I want. I have a branch or the main duct is 20, and when we branch out, we can reduce this pipe because I don't need 20 anymore. I need 16 here. So I only need 20 in this last part of the duct because I'm connecting to 16-inch branches. But, well, can I explain what I did? I don't know, probably if I did it again, it would be different. But that's the goal, okay? So I need a branch here, and then I have to make sure that all these things are connected. This is 16, and this should be 16 because I'm not adding anything else. And when we add another 16, then that should become 20. Do you get it? Well, take your time. This is probably the most difficult thing we can do today. And in Revit mechanical systems in general, this is probably the most difficult thing. Connecting two horizontal branches to a vertical pipe. And after the first branch, we have a reduction, and then we connect this to this one. What if we check the flow now? What should be the flow here? At the end of the, well, at the end of these branches, let me check on level 0. This is 700, 700, 700. This is 2100 plus 100. So this should be 2200. It is 2200. It works. Okay. Then on level 15, this one should be 2200. And it works. It's 2200. So on level 30, if we have two branches of 2200, this should be 4400. If I click here, this should be 4400. So it works. Why do I have these nice colors here? And because, well, there is in architecture, we can view or in view. Okay, there's a way to change the colors because it's very useful because we're dealing with supply. But when we're dealing with supply and return, it would be great having two different colors. But anyway, we will talk about this next week. So do you think, okay, keep working because that's the end of the lesson today.